Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra and today we are going to solve the problems of problem session 1, that is Kinematics level 1. I have already given you the problem sheet and I will be solving from question number 11 onwards today. I have solved question number 1 to 10 in previous two videos. So let's begin. Two particles start simultaneously from the same point and move along two straight lines, one with uniform velocity v and other with uniform acceleration a. If alpha is the angle between the lines of motion of the two particles, then the least value of relative velocity will be at time given by. At time, say, let's cut at time, the least value of relative velocity will be given by. Now, let's see what this question actually says. This question demands, if first there is a particle which is moving with a constant velocity v, there is another particle which is moving with an acceleration a, constant acceleration a. So at time t, it will be a into t, since it starts from rest. Nothing is given, so I am assuming rest, and the value is alpha. Now let's calculate the magnitude of relative velocity of the particle. So it is v. So I am assuming that in the backward producing of the vector v, so it will be minus v, and now I can, since this is v relative, the relative velocity vector, so I can just find the magnitude of v relative. That will be v square plus at whole square plus 2v at cos 180 degree minus alpha. So that is the v relative. Now if we can differentiate this with respect to time, we can get the value of v relative. Now just see the concept here, what I want to say. See, this is v, this is constant. When it is very small, that time it will be inclined like this. When it is something like this, then it will slowly increase. Now when it is increasing very large, that time also it will increase. So there will be a time when this relative velocity will be minimum. So that we have to find. So I have already solved it here. See, the relative velocity has a magnitude of v square plus at square plus minus of 2vat cos alpha. So v relative whole square, that is v square plus a square t square minus 2va cos alpha into t. So differentiating this 2v relative dv relative by dt is equal to v is constant, so 0. A square is a square, t square is 2t minus 2va cos alpha into t, 2va cos alpha. So dv relative by dt is equal to 0 for maximum. We know if we have problem in this part, how for maximum why the differentiation is 0, then you can watch our basic calculus for physics video. Now t is equal to 2va cos alpha by 2a square from here. So t is equal to v cos alpha by a. So our correct option is option B, v cos alpha by a. Now our next question is that what is there is an inclined plane here, and a projectile is projected, here with the velocity, say with an acceleration, a velocity is projected here, and this is 30 degree, and with a velocity u 10 meter per second, and alpha with respect to the ground. That means what is given here, this is 60 degree, this whole with respect to ground. So now I have to find what is the range of the projectile. This range, what is the range of the projectile? This is u. Now I can let me find out here what we have to do. We have already solved this in our theory classes, the same question, and let's do it once more here. First of all, let's draw the situation. This is 30 degree. The projectile is launched with a velocity u, and this is also 30 degree. Now the projectile is following a path like this. This is g. This will be my g sin theta. This will be my g cos theta. Now we will be resolving this into two components now. what we are doing here, we are assuming the x-axis is like this and y-axis is like this. Now x is equal to u cos 30 degree t minus half g sin 30 degree, here theta is 30 degree, g sin 30 degree into t square. Y is equal to, say y for this is u cos theta and this is ux, this is uy. Y is equal to u sin 30 degree into t minus half g cos 30 degree into t square. Now this y will be equal to 0 for the 2 points at which it will touch the plane, and above that it will stay on the ground. So for y is equal to 0, I have already done the calculation here. You can see here I have done it. Y is equal to uyt plus half ayt square is equal to 0 for time of flight. Y is equal to 0 for t is equal to 2uy by ay, or t is equal to 0, so in between them. So capital T will be 2uy ay minus here minus 0, that will be the same thing here. So uy I can write here u sin 30 degree, u is 10, so 10 sin 30 degree by 10 cos 30 degree is equal to 2 by root 3. I'm getting. Now we are putting this 2 by root 3 in our x equation. This x direction, the motion for a complete time of flight, the horizontal displacement or the displacement along the x direction is x, r range. So ux into capital T plus ax by 2 into capital T square. So 10 root 3 by 2 into 2 by root 3 minus 10 into half into 2 by root 3. The answer gives 20 by 3 meter. So this full thing we had already discussed in details on a previous video. Please watch our projectile motion lectures if you find difficulty in solving this kind of problems. We also have an alternate method for this question. That is, let's look at the alternate method once. First of all, we will consider, let's say this is an inclined plane. We'll consider the complete trajectory of the projectile. This trajectory of the projectile, I can represent by this equation: y is equal to x tan 60 degree minus 10 x square by 2 into 10 square cos square 60 degree. By substituting the values, we get y is equal to x root 3 minus x square by 5. Now what is the equation of the line along the plane? Equation of the line along the plane, this one, this equation along the line along the plane, this is 30 degree and this total is 60 degree. That is why I took 60 degree here and not 30 degree. That is the angular projection. Now that will be tan 30 into x, that is x root 3. Now if we solve these two equations, we'll get this point, that is the point of intersection. Then we'll get x. Now this is x, but we are interested to find this r. So we can find r is equal to x cos 30 degree, x by cos 30 degree. We'll do it. Now let's solve this equation. Let's put y is equal to x by root 3 here. So y is equal to x by root 3, x by x root 3 minus x is 5. Since x is not equal to 0, we will get x is equal to 5 by 2 root 3 is equal to 10 by root 3. Now x is equal to r by cos 30. See this triangle. If we have to find r, then we have to do x by cos 30 degree. X by cos 30 degree, 10 by root 3 divided by root 3 by 2. That will come out 20 by 3 meter. You can do any problem, any method you want, and if you are facing any problem, then watch our projectile playlist. Velocity of projection of an oblique projectile is u vector is equal to 6 I cap plus 8 j cap meter per second. Horizontal range of the projectile is. See, what does it mean by oblique projectile? The projectile is not launched straight up in the air. It has been launched with an angle whose components it has been given. The horizontal component is our 6 I cap and 6 meter per second, and the vertical component is 8 meter per second. Now it is asked to find the horizontal range. See, there are two formulas for range. One is u square sine square alpha, u square sine 2 alpha, the maximum range, the range, u square sine 2 alpha, the horizontal range, by g. The other formula, which is a less known formula, but this is a standard formula which I have already shown in my lectures, that can make this problem very easy to solve. That is r is equal to 2 into ux uy by g. When it is given in the form of components, just use this formula. So 2, what is 2ux? 2ux is x, uy is 8 by g. Let me assume it as 10. So 6 2s are 12, 8s are 96, 96 by 10, that is 9.6 meter. If you are facing problem how this formula came, then please look at my projectile lecture. See this formula, how simple it becomes. Ship A is moving westwards with a speed of 10 km per hour, and ship B 100 km south of A is moving northwards with a speed of 10 km per hour. The time after which the distance between them becomes the shortest. Okay, 5 root 2, 10 root 2, 0 and 5 hour. Let's see what it is telling. See here. I have here what I'm showing you. I have say ship A, it is moving towards the west. See, let me draw the directions here. This is north, this is east, this is west, this is south. Ship A is moving towards the west with a velocity of 10 km per hour, and just 100 meters south, 100 kilometers south, sorry, ship B is moving up with a velocity of 10 km per hour. Now we are asked to find the time at which the displacement between them, or the distance between them, will be minimum. Let's see, the ship B is walking along this line, moving along this line, and ship A is moving along this line. At time t, ship A is at this point, ship B is at this point. Now we will be joining these two lines by this, and this, let me assume that this time is t, so it will go by 10 into t, speed into time, there is 10 into t time displacement, and this will also go to a displacement of 10 into, displaced by 10 into t. So this part I can say this is 100 minus 10 into t, and this is 10 into t, and this is d. So I can write d square by Pythagoras theorem is equal to 10 into t whole square plus 100 minus 10t whole square. So now if we differentiate this, then we will get the value of t. Exactly that what I have done here. See, d is equal to, d square is 100 minus t, 10t whole square plus 10t, 10 square t square. Differentiating will give us 2 into 100 minus 10t minus 10 plus 10 square into 2t. dt by dt is equal to 0 for maximum value of d. So 2 into 100 minus 10t is equal to 10 into t. T is equal to 5 hours. See, it is given in kilometer per hour. So I have to find the answer as in hours. So our correct option is 5 hours. A projectile is fired from the surface of Earth with a velocity 5 meter per second and angle theta with respect to horizontal. Another projectile fired from another planet with same angle, there will be same, that is missing, with same angle and same angle, both case, and 3 meter per second speed follows an identical trajectory. Find the acceleration due to gravity of the planet. See, on Earth it was given 5 meter per second square, 5 meter per second, and on another planet is given 3 meter per second, and angle is same. Just see the thing. Both are following the same trajectory. So can I start with the trajectory equation? Let's begin. On Earth I am showing with orange. No, Earth is blue, so I will be showing with blue. Y is equal to x tan theta minus g square, g x square by 2, what was u? U was 5. 2 5 square cos square theta. Okay, this was Earth. Now the planet, let's say it is Mars, so it's the red planet. Y is equal to x tan theta minus g x square, g dash, because it will have a different acceleration due to gravity, g dash by 2 3 square cos square theta. Now for these two to be equal, we will be comparing the terms. Same. Here these are the problems. See, if I can equate g dash by 5 square is equal to g by 5 square. for the earth, let me write the earth terms in blue. G by 5 square, if I can write, that is equal to, if I can write G dash by 3 square, I will get the answer. So what is G dash is 3 square by 5 square, that is 9 by 25, and what is G? G is 9.8. So 9.8 into 9 by 25, that will be approximately, that will be, I have solved this question, that will be approximately 3.5 meter per second square. That will be 3.5 meter per second square. So the ultimate keyword is trajectory. If we can identify the keyword, the question becomes very easy. So we'll just equate the both trajectories. Thank you. So that's all for this video. We'll be solving the next problems in the next video. So please subscribe to our channel and share this video, and please solve these problems by your own method also, because when you are solving by your own method, then you are learning, and after that you watch this solution, so to understand where you went wrong, or in which other ways this problem can be solved. And if you find any better method to solve any problem, then please give the answer in the comment section. Please mention the method. We'll try to acknowledge that. Thank you.